today, just to give you a wholesome picture of whatever you have studied up till now, we will take up a case study which is a collation of all the data by one single research group, how they began and how at every stage, using the strategies which you have studied in plant cell technology or plant cell bioprocessing, at every stage there could be an enhancement in the productivity up till the reactor level. So, the study was done for the secondary metabolite azadirachtin, which is a biopesticide. So, I will not take up the advantages, disadvantages of these. Biopesticide everybody knows. So, basically the biopesticide was azadirachtin. Azadirachtin is present in a ubiquitous plant, which is your neem. It is present everywhere. So, azadirachtin is found on all the parts of the plant. However, it is collected commercially from the seeds of this tree, and this seed formation happens twice in a year. And moreover, but there are disadvantages, as I have mentioned before also, that generally ripe seeds are collected which have maximum concentration of azadirachtin, but this also has a lot of sugar content in it, because of which there are pathogenic contaminations, especially fungal pathogens, and it is known that, and companies face problems once they collect and there is a contamination with these fungal metabolites, which some of these are carcinogenic like aflatoxin. It is a highly complex big molecules, lot of chiral centers. So, complete chemical synthesis has not been reported yet. So, this is the molecule and it has a wide mode of action into number of pests known in different plant varieties. So, that is the reason why it is a very looked forward and high in demand biopesticide in the market. Now, the reason being, one is it has a very diverse mode of action, then completely biodegradable, that is a big advantage, and non-toxic to other organisms. It has a specific mode of action towards pathogens. So, what they had proposed was a plant cell and tissue culture based bioprocess for in vitro production of azadirachtin, because the disadvantage associated with nature were that you will find neem present everywhere, but the limitation is that if you collect it from different parts of the country, you will find that the yield of azadirachtin is variable. It is season dependent, it is plant age dependent, geographical location dependent, and moreover the collection problems with the material. So, the two kinds of approaches were used, plant cell suspension based and the other was hairy root culture based. I will be talking in detail about plant cell suspension later if we get time in subsequent classes once you are making the presentation, and if I find the need, then I will also talk about the hairy root culture process. So, for the plant cell suspension cultures, the objectives which were laid down were to establish the cell suspension of A. indica for production of azadirachtin under in vitro conditions. So, one had to establish a high yielding fast growing plant cell suspension culture of Azadirachta indica. Then to develop different strategies for enhancement of azadirachtin production in the cell suspension culture. So, which means that you also develop strategies how to further improve the yield and productivity of azadirachtin. Now, yield was per unit biomass yield, which means inherent capacity of the cell line to produce that product, which was azadirachtin, and the second was the biomass also, so that the overall productivity or the titer levels could improve, because azadirachtin is an intracellular product. Then once you had a high yielding cell lines and then on that cell line you developed the cell suspension culture. In that development of cell suspension cultures, you optimized all the strategies which could further improve the productivity. Now, all these optimized conditions were integrated in a bioreactor. So, first, before taking it to the reactor level, a suitable bioreactor was selected. It based on the mass transfer and the mixing time characteristics. ultimately it was based on substrate utilization rates, product formation rates and biomass formation rates. So, once a suitable reactor was selected, then in that reactor a batch kinetic study had to be established. Once the batch kinetic study was established, you get to know what? When we say batch kinetic studies, they were able to see what is the kinetics of growth in that selected reactor, what is the kinetics of product formation. Once we knew that this is the kinetics of product formation, substrate and growth, then all these three were made, given a form of mathematical equation which was called as a model, such that this could be manipulated in silico to develop feeding strategies to further improve productivity at the batch reactor level. Now, for further improving productivity from batch, what is generally done to remove the nutrient limitation, which is done by feeding the substrates. Now, as you all know, you have already studied that feeding can be done in various different ways. So, what should be the feed concentration, time of feed and the duration of feed and the way you feed, whether exponential feeding strategy, constant feed strategy, intermittent feeding. So, all that you cannot afford to do experiments to design, hit and trial. There will be n number of permutation and combinations. So, that was the reason why modeling was important. Once model was in place which was robust by fitting the batch data into those set of equations, then this model was extrapolated for fed batch and continuous cultivation, and in silico feeding strategies were designed in fed batch and continuous cultivations, and the best strategy which was selected was experimentally verified. So, we will see how the complete steps led to enhancement in productivity and which was more than what is present in nature. So, what was done? I said what is important is to begin with the high yielding cell line. So, first thing is to collect the different plant variety material from the country. So, almost if I am right, there were some 30 seed varieties, because seeds are known to be highest. So, 30 seed varieties across the country were selected and they were screened for the azadirachtin yield in them. Once the highest yielding seed variety was found to be the Trivandrum variety, which was then taken forward to develop cell lines. Now, assuming that, as I have mentioned before, a highest yielding plant would lead to a high yielding cell lines. So, that was the logic behind. Once this was done, callus was induced. Now, each callus lines which will be induced will have a different genetic makeup and therefore a different biosynthetic capacity. Again, screening and selection of cell lines was done based on the growth index and azadirachtin yield, and then finally the highest yielding cell line was selected. Now, this cell line, once callus line which was selected, was taken forward to develop liquid culture, which was suspension culture. Now, before going on to do any kind of optimization in suspension culture, what is important? To know the reference level. Reference level means from what level I need to improve. So, for that I need to know, once I have developed the suspension cultures, again a batch kinetics in the shake flask at a small level was plotted. Batch kinetics was plotted and it was found that which day should be the harvest day in that batch kinetics. So, ultimately what is the summary? Now, the reference point for us to have better productivities for any kind of optimization would be what? 12 days, the biomass is 5.9 grams per liter, which is maximum biomass, and your azadirachtin titer, which is a club of biomass and yield. So, actually that is your reference point. The azadirachtin titer is 9.3 mg per liter, okay, which is on the 12th day, end of the log phase. Now, this becomes our maximum possible azadirachtin titer in the given conditions of shake flask. Now, when the suspension culture was developed, it was developed in MS media. So, a number of basal media were selected and then the callus line was, the suspension culture was developed in different basal media. This is what was done. Different basal media, which means known compositions like B5, Gambogg's medium, Erickson, MS, Niche, Whites. These are different pre-defined media for plant cell and tissue cultures. We have discussed that. So, in these media the cell line was grown, the suspension was developed, and based on the azadirachtin titer yield and biomass, MS was selected for suspension culture for further optimization. Now in this, because MS is generally what carbon source is used in plant cell and tissue cultures? Sucrose. Now it was important because sucrose is easily available, economical than the other carbon sources. Fructose can be only be preferred because fructose is expensive if it is really making a remarkable difference. So therefore what the group did was they picked up glucose, because ultimately glucose is easily metabolizable. So they did a kinetic study to see how in comparison to sucrose if glucose was giving much higher yields. So they did this initial study and they found that glucose was giving better yields than the sucrose. So for further optimization in MS, now MS contains major and minor salts, carbon source is separate. Carbon is then glucose which was utilized. So this kinetics on the right hand side, so then you can see that glucose was found to be a better carbon source than the sucrose. It will be nice to know what range should be selected for studying the interactive effect. So in order to select the range for the interactive effect study using statistical tools, your design of experiments, single factor experiments were carried out in which each of these major components were varied in a range and the effect on the biomass and azadirachtin was observed. Based on this, they could get a rough idea that where it is highest, so that the plus minus could be further increased or decreased to get to the maximum, the optimum value using statistical design of experiments. So they did for phosphate, nitrate, ammonia, glucose, and they also did nitrate ammonium ratio study, because it may happen that the culture may not prefer ammonia over nitrate or may prefer nitrate over ammonia. So then in that case it was important to study nitrate to ammonium ratio. Interestingly, what they found in MS, it is 30:30 if I am right. Absence of ammonium is giving the highest azadirachtin yield. So which means that you can, while studying the interactive effect, you can even discard ammonium or keep the ammonium at very low concentrations for plus minus range. Then they also studied rest of the major factors. Then based on their single factor results, then they created plus minus levels for the screening of the most significant factors in these selected major components. There are 6 major components, 1, 2, 3, 4, 5, 6. Now out of these 6, if you design and start optimizing using statistical design of experiments, it will go up to some more than 100 experiments. So what will be more intelligent step would be that first to see how significant each of them is and then select only the most significant, top 2 or top 3, top 4. So this is what they did. They did a Plackett-Berman design, which is a screening design in which they could able to find out which and how these 6 are impacting individually the growth and the azadirachtin yield. They could then rank these based on the ANOVA results. Then the statistical analysis is done, and based on that analysis you can even rank the factors based on the model which comes out and the coefficients associated with each of those main factors. So then based on that, what could they find? That the inoculum level, calcium chloride, nitrate, glucose were critically affecting growth positively, and glucose, nitrate, phosphate and inoculum level were affecting azadirachtin. Now our idea is what? To get maximum titer of azadirachtin. So but it is always recommended to do these optimizations for independent factors. It should not be aliased or it should not be clubbed, because if you will take titer, you will never be able to find how is one affecting these 2 independent factors, the biomass and the azadirachtin yield, if you will take titer as your single response. So because if you will do it individually, you can even design a 2-stage cultivation which can give you higher productivity than a single batch. If you will do it for only titer, then this will work only for batch. and then you will have to apply other strategies for further yield or productivity enhancement. But if you will do individually, who knows if it is a really completely non-growth associated product, then it is better to run it as a two-stage. So, for that, in the first stage you would like to feed in nutrients which are best for growth, and in the second stage you would like to feed in nutrients which are best for the secondary product. But it depends, if it is mixed growth associate or growth associated, then you can take the titers. So, this was the analysis done. Based on the response surfaces, they could optimize. So, it effectively tells you that the x axis and the y axis component, how the pairs would be, the data would be affecting the growth or the azadirachtin. If you see clearly on the azadirachtin plot, there is no convergence point in the design space, and the convergence point was maximum azadirachtin, isn't it? That was the goal. So, if you see that there is no, even if in the range selected, there is no data point which is converging. They could have added more contour plots, that would give us much clear idea. It is dependent on the user, you can keep adding and see the convergence point. So, I am not very sure if the convergence point will lie within the design space, which means that there is a need to go back and see the range selected. But because for us it is dependent on both the biomass as well as the secondary metabolite yield, so then it can be even with whatever you have, you can get to further improved result from the unoptimized. So, this is what happened here. Even with that, whatever maximum they could reach through that contour optimization, they could define a media composition based on this contour analysis. See, there is no the model, it is always a model. So, you cannot claim that this is the maxima, there can always be scope. So, it is acceptable, but till the time that it is giving you better results than the reference point. So, now the glucose, nitrate, phosphate and inoculum level were optimized, and if you can see here, the biomass the predicted was 15 and the azadirachtin was 3 mg, and here it is 2.9 mg per gram. Now, then what did they do? They did auxin cytokinin growth regulator single factor studies in different ratios, and they could find that IBA and BA were found to be in this ratio, could give maximum azadirachtin titers. Now, see, this is also improved from your reference point. Then they did agitation speed study. Now, what is important? Although mass transfer I said with agitation would improve, but the effect on the viability is also crucial to see the overall effect on the productivity or titers. So, they did a kinetic study in which they saw how the biomass is changing with time with increased RPM. So, if you can see the plot, you can see beyond 125 RPM, the viability of the cell started going down. So, 125 RPM was found to be the optimum speed for maintaining the viability. Then pH temperature optimization was done, being an interactive factors, again statistical design was used, and then if you see here clearly, the range seems to be fine because they are effectively converging, and this will give you the ideal results what you expect for optimum values of pH and temperature. So, now if you see the comparison, unoptimized conditions, the growth and the azadirachtin overall it was 7.8 titer, but if you see the optimized conditions, it had improved to 47.1 mg per liter. So, this is just through simple media optimization. Now, let us see, there are other strategies which can further be used to improve the yields and productivities. They did elicitation. These are the different kinds of signaling molecules, abiotic, biotic elicitors. They tried these elicitors in different range. Now, in different range, these were all single factor experiments. They could select salicylic acid which was giving as high as 138 around mg per liter at that concentration, and also they could see that chitosan was also giving approximately the same enhancement up to 138, 140. So, then what did they do? They, for multiple fold enhancement, they chose the 3 best elicitors at the range which they could see through these single factors, and they did an integrated study to have a synergistic effect. They did again CCD, the statistical optimization. This statistical optimization again gave them better results. Now for this the response would be what? It is an yield enhancement strategy. So generally elicitor addition, it is well known that it would lead to reduction in biomass. So time of exposure to the elicitor is crucial, and the response while selecting the elicitor can be yield rather than having titer, because you would never add the elicitor on the 0 day. You would add the elicitor for an optimum exposure time such that growth of the elicitor. So while selecting the elicitor, what did they do? In this CCD design, if you will see, your response was azadirachtin yield. Based on this, they could find the optimum concentrations of these 3 selected elicitors, which could lead to maximum enhancement in azadirachtin yield. So now it has gone up to nearly 16 milligram per gram. Now as I said, they again did time of addition. For this selected elicitor pack, what should be the right time of addition so that there is minimum loss in biomass? So then they did, and they found that with 48 hours of exposure, which means adding the elicitor just before 48 hours of the harvest. So harvest time for the batch was 12 days, if you remember. So they added 48 hours, 72 hours, 96 hours, 24 hours before that, the harvest day, and they found that giving an exposure period of 48 hours is good enough to get the maximum yield enhancement. Later it has dipped, maybe because of the viability of the cells getting affected. Now this is a good way, but what else can be done? Then they also did precursor addition. Now for precursor addition, what is important? To know the biosynthetic pathway. Now in that biosynthetic pathway, the more you add exogenously, one is the availability of the exogenously added precursor is crucial, and the concentration of the precursor is crucial. So they chose the upstream intermediates so that the probability is high of it being available for the secondary metabolism. So then they chose some of these precursors in the biosynthetic pathway for exogenous addition in a different range. So this was again a single factor study, and they could choose IPP, then GPP, geranyl pyrophosphate, then squalene, that's not going back, mevalonic acid lactone. And what could they find? They could find that GPP at certain concentration level was giving more than 100 azadirachtin. Then they did, so these are all independent experiments. So there can be 2 ways of optimizing. One is you can run a relay system, the other is you run a parallel system and then finally integrate. So because everything, if you wait for a relay system, it may take long time. So generally you will observe people do independent studies and then finally integrate as a combined study to see synergistic effects. So then permeability enhancement was also checked. They used certain permeabilizing agents which are known in literature in concentration range which are well below to affect the viability, but still because it is species dependent, so viability was checked. So at different concentration range, these are all surfactants, solvents, so percentage volume by volume, they were concentration range was added, and they could find that N-hexadecane at 5% volume could give you azadirachtin release up to 13%. Now why do you think there are other these permeability enhancers which are giving very high release? I see it is going up to 70% decanol, but why they have chosen N-hexadecane with 5%? Cell viability, which will impact your biomass, and these were added on 0 day. So then once all these strategies, and we came to know that these are the strategies which are leading to enhancement you have selected, then what is important? To choose the right reactor for mass cultivation. For that, what was done? Batch cultivations were carried out. First, even in the stirred tank reactor, I mentioned that the shear forces can be varied by changing the impeller design. So then they did a study in which in the same stirred tank reactor there were different impellers which were used based on their mass transfer coefficients and mixing time characteristics. So they tried with Cetric impeller, which is a low shear impeller known for plant cell cultivations. They tried with centrifugal impeller, which is also a new design well known for very low shear forces and very good mass transfer efficiency. So they tried these two configurations, and they also did pneumatic reactors in which they used bubble column reactors. And for this, then they drew the kinetics in each of these reactors. So first is the simple reactor, which is easy to scale up, which is your stirred tank configuration, well known in industry. So stirred tank configuration, Cetric impeller was used and the kinetics was drawn. So what could you see as a change once it was brought from the shake flask to the reactor? Any advantage? What was there in the shake flask? Very good. So the productivity could be enhanced because the kinetics was faster now, and the probable reason could be the maintenance of controlled conditions. Then centrifugal impeller was used. Now again the kinetics was drawn. So you can see that the biomass has been improved and the hexadirectin content also has improved in 10 days. What could be the reason? They drew biomass formation rate and product formation rate, and they could see that, you can see from the figures, that centrifugal impellers leads to better biomass formation rates during the cultivation period and also better product formation rates. So they wanted to justify what could be leading to this. So they calculated KLa under the given operating conditions in which the reactor was run. They calculated KLa and they also calculated the mixing time. After calculating, can you see which one is better? Which one is better? Why? Because KLa is better and is less. So then pneumatically agitated reactor was used if no moving parts are there in the reactors. So they could see that the dry cell weight was equivalent, but the growth rates have gone low. You are achieving it in 12 days. So which means that maybe because of better mixing, because of the moving part inside the reactor. So one should prefer a stirred tank configuration rather than pneumatic reactors. So they did a comparison with the Cetric. This was with the improvement was with in comparison to the centrifugal impeller, where it had improved to 18.7 and 72. So if when they did a comparison in terms of Cetric impeller, they could find that the biomass formation rates and the product formation rates were better, but if you compare it with the centrifugal impeller, the bubble column was lower. So finally a stirred tank reactor configuration with centrifugal impeller was chosen for further studies.